Hi students, I am Sumalata. In today's class, I am going to explain about dioxygen. Dioxygen is nothing but oxygen, O2. Okay, you already know so many uses there, so many things related with oxygen only. We are living only because of oxygen, only because of oxygen. Without oxygen, we can't able to live. Especially we are, it is used in respiration. Okay, breathe in, breathe out, and then combustion reactions. If astronauts are there, they are going there with the oxygen cylinders, and in hospitals and welding shops, and so many uses are there. Okay, if you take sea water, you can see you can take once for every 100 centimeter cube of water. The dissolved oxygen is the 3.08 centimeter cube at 293 Kelvin temperature. At 293 Kelvin temperature, the dissolved oxygen in 100 centimeter cube of water is the 3.08 centimeter cube oxygen. This is the sufficient for marine and aquatic life. This dioxygen is the colorless gas, colorless and odorless gas. If you take dioxygen reactions, the dioxygen reacts with most of the metals and non-metals except noble metals like alum, platinum, and also noble gases. You already know helium, neon, argon, krypton, xenon, radon. These are the noble gases. Okay, with these elements, the oxygen should not be react. If you take gold, why gold having same weight? If you when the time of buying and also time of selling, because it won't be oxidized with oxygen. If any piece is missing, if it is broken, then only its weight will be reduced, otherwise it won't be reduced. Because if anything is going to be reacting with oxygen, that nature will be changed, that will completely changed, so that some inert elements, inert gases will not be react with oxygen, so that their nature won't be changes. Okay, their weight and their properties won't be changes. Then coming to preparation methods of dioxygen, if you see, especially oxygen containing salts, nitrates, and dichromates, you can take all these things under heating. They will in presence of a catalyst, they will give dioxygen as a product. You can see KClO3, KClO3 2 moles you can take here. MnO2 used as a catalyst and heating, then you will get KCl and O2 gas. This is the dioxygen gas. Okay, how many moles here? 3 moles. You can write 3 moles. 3 moles of O2, because here we have seen we have taken 2 moles O3, so 2 moles you will get. And next one is if you see metal oxides, the metals present in metal oxides having low electrochemical series, nothing but low reduction potential. Those are, you can see AG, silver Az2O, silver oxide, 2 moles you can take. So 4 moles silver, silver oxide converts into silver reduced into silver solid, metal, pure metal, and then O2 gas will be formed. Okay, and then also HgO, okay, it will also gives you Hg, it will separate Hg. Here mercuric oxide reduced to mercury and will form oxygen. Here Hg is the liquid, oxygen gas. Next, some higher oxidation state containing metal oxides also going to be produce oxygen. Pb2O3 you can take 2 moles Pb2O3, it will gives you 4 moles of Pb plus 3 moles of O2 gas. Okay, this is also solid here. And also 2 moles of PbO2, that is the trioxide, this is the dioxide. Lead dioxide will gives you 2 moles of lead solid and also 2 moles of O2 gas. And another preparation methods, if you see, um, electrolysis of water. Electrolysis of water gives hydrogen gas at cathode, oxygen at anode. You can see electrolysis of water. Here you can take 2 moles, so you will get 2 moles of H2 gas and 1 mole of O2 gas. See it at cathode H2, at anode O2. Okay, and also decomposition of hydrogen peroxide H2O2. Here this one also you can take 2 moles, so you will get 2 moles of H2 gas and 2 moles of O2 gas. Not H2 gas. Here you will get H2O, because we are using in our ears to clean our ears, we are using H2O2, not H2 gas. So sorry, that one. So you will get water, 2 moles of water and 1 mole of oxygen gas. Okay, and another preparation methods are especially oxygen also separated from atmosphere by liquefaction and fractional distillation. In the first step, we are going to separate carbon dioxide and water in the form of moisture, carbon monoxide. All these gases going to be separated in the first step. Then the next step, we are going to be extract nitrogen gas and oxygen gas. Okay, these are all the preparation methods of oxygen. Then we will move to chemical reactions of oxygen. If you see chemical reactions, just now previous I told you, oxygen will not react with noble metals and noble gases. Especially it is going to be reacting with most of the metals and as well as non-metals also. So you can see those reactions. Oxygen reacts with carbon, it will form carbon dioxide, and also it will form carbon monoxide also. Okay, then you can take zinc oxide. You can take zinc sulfide 2 moles. It will gives you zinc oxide and 2 moles of sulfur dioxide. See here you can take 3 moles of oxygen. Okay, then coming to next one, if you take copper is the metal. Calcium, you can take calcium, 2 moles of calcium react with oxygen will gives you calcium oxide. And also you can write aluminum, 4 moles of Al will reacts with oxygen, Al2O3 will form. So 3 moles you can take, 2 moles of Al2O3 will form. In the same way, hydrochloric acid also reacts with aqueous hydrochloric acid reacts with oxygen. It will form 2 moles of Cl2 gas and 2 moles of H2O will form. So no need to take water here. Okay, see how many moles oxygen needed here? Only 1 mole. So here see 2 moles of chlorine, 4 chlorine atoms. Okay, enough. It's balanced only. Okay, next if you see a few more reactions. This is the catalytic oxidation. Nothing. See here, CuCl2 used as a catalyst. And also, if you see, oxygen reacts with methane gas. CH4 you can take. Oxygen will gives you carbon dioxide and water. So you can take 2 moles of oxygen. Okay, 2 moles of oxygen. And also few oxides oxidized in presence of catalyst. You can take SO2, sulfur dioxide react with oxygen, it will in presence of V2O5 as a catalyst. So you will get SO3. 2 moles of SO2 you can take, 2 moles of SO3 you will get. Okay, and a few more reactions. Phosphorus in the form of P4 reacts with the oxygen, you will get P4O10. P4O10. These are the few preparative methods, not preparative methods, chemical reactions of oxygen. Then we will go to what is the basic nature and acidic nature, what are the acidic oxides, basic oxides, and amphoteric oxides. So once you check all these chemical reactions, generally oxides may be simple oxides or mixed oxides. Okay, if you take an oxide reacting with water, if it will forms an acid, that oxide is the acidic oxide. If an oxide react with water, if it forms a base, that oxide will be the basic oxide. If an oxide shows both acidic and basic nature, that will be the that will show dual nature, that is the amphoteric oxide. Few oxides are not show any nature, maybe acidic or maybe basic, they will not show any nature, so they are comes under as a neutral oxides. Neutral oxides you can take examples CONO, these are comes under as a neutral oxides. First acidic oxides you can see. Acidic oxide, suppose SO2 reacts with water, it will form H2SO3. okay, this is an acid, so that it is the acidic oxide. It is the acidic oxide. Suppose you can take few examples for acidic oxides. SO2, next N2O5, next and some few examples you can write. Okay, then you can come basic oxides. If an oxide will gives base while reacting with water, that will be the basic oxide. Ca you can take calcium, and water will gives you CaO, calcium oxide. Okay, that is the calcium oxide will gives you calcium hydroxide. This is the basic oxide, it will gives you base, so that it is the basic oxide. You can take few examples about this one. Here you can write a few examples: Na2O, CaO, BaO, barium oxide, calcium oxide, and so on. Okay, there you examples are SO2, N2O5, CO2, Cl2O7. Okay, these are the basic oxides, and these are the acidic oxides. If you take amphoteric oxides, suppose Al2O3. Al2O3 reacts with HCl, 6 moles of HCl, and 9 moles water. You can take 9 moles of water. It will forms 2 moles of AlH2O, taken 6, 3 plus, and 6 Cl minus ions. Okay, this here it is going to be acting as a acid. Next you can write one more example: Al2O3 and 6 moles of NaOH, 3 moles of water you can take. Okay, here 2 moles of Na3Al H2O, AlH2O. Here how many moles of water is there? Hydrogens 3 moles AlH2O, taken 6 you can write, taken 6. Okay, here it is showing acidic nature, and it is here it is showing basic nature. Okay, so that it is the amphoteric oxide. It is the amphoteric oxide. Amphoteric oxide. In first case acidic oxide, second case basic oxides. Here in this reaction it is going to be acting as an acid here, and nothing but acidic oxide. Here it is acting as a basic oxide, so that it will show dual nature, that is a amphoteric nature. Okay, this is about your class, today's class. I think you are all understand about this one. If you have any doubts, please mention your words in comment box. Please do subscribe, share these videos to your known people. We will meet in the next class. Bye, I love you.